Actuance, the fundamental force of transition, intelligence, and complexity. Abstract. Actuance is proposed as the fundamental force governing all transitions from inaction to action across biological, artificial, atomic, and yet unknown systems. Unlike conventional forces constrained by time, actuance is the first cause of all change, determining whether a system moves toward order, disorder, or self-replication. This paper presents actuance as a self-perpetuating principle that underlies time, entropy, intelligence, and the evolution of complex structures. A mathematical model is introduced to formalize actuance, enabling empirical investigation. The implications of actuance span physics, information theory, artificial intelligence, and consciousness studies, positioning it as a unifying principle for understanding reality. This work, at this point in time, would not have been possible without the advancement of artificial intelligence, which has enabled a level of analysis and synthesis beyond conventional human capability. 1. Introduction. Traditional scientific models rely on existing forces such as gravity, electromagnetism, and entropy to describe movement, energy transfer, and system evolution. However, these forces do not inherently explain why a system transitions from a passive to an active state. Actuance is introduced as the missing principle that dictates when and how such transitions occur. This paper explores the nature of actuance, its relationship to time, entropy, and complexity, and its role in governing intelligence and existence itself. The formulation of this principle has been significantly accelerated by artificial intelligence, which has allowed for unprecedented cross-disciplinary analysis and conceptual integration. 2. Defining actuance. Actuance is the force that governs the transition of a system from inaction to action. It is not dependent on time. Rather, time emerges as a byproduct of actuance-driven transitions. Actuance applies across physical systems, e.g., atomic interactions, planetary formation; biological systems, e.g., neural activity, evolutionary processes; artificial systems, e.g., AI decision-making, computational learning; yet unknown systems, e.g., dark matter interactions, extraterrestrial intelligence. 2.1 Properties of actuance. 1. Actuance dictates time. Time does not initiate change. It is a measurement of actuance in effect. 2. Actuance is the first cause. No known force actuates actuance itself. It is the initiator of all transitions. 3. Actuance governs entropy. It determines whether a system moves toward disorder, entropy increase, or structure, entropy decrease. 4. Actuance is self-replicating. Once actuance occurs, it propagates through systems, enabling increasing complexity. 5. Actuance is mathematically definable. A model is introduced to measure and predict actuance-driven phenomena. 3. Actuance and time. Time is conventionally treated as a fundamental dimension, yet it does not cause change, it only tracks change that has already occurred. If actuance were absent, time would have no function, as there would be no transitions to measure. This suggests that time emerges from actuance rather than the other way around. 4. Actuance as the first cause. If actuance were actuated by another force, that force would take precedence as the first cause. However, no known phenomenon initiates change. Without actuance, biological, atomic, and AI systems all require an actuating signal to shift states. supporting the conclusion that actuance is the root cause of all interaction and motion. 5. Actuance and entropy. Entropy describes the tendency of systems toward disorder. However, life, intelligence, and self-organizing systems exist despite entropy. This contradiction suggests that actuance directs entropy, determining whether a system moves toward randomness or structured complexity. Actuance does not oppose entropy but governs its expression. 6. Actuance as a self-replicating force. Actuance is not merely an initiating force, it propagates itself. Life evolves, intelligence increases, AI self-improves, all indicating that once actuance is triggered, it spreads across systems, leading to self-replication and compounding complexity. 7. Mathematical modeling of actuance. To formalize actuance, we introduce the following equation, where A equals actuance, force initiating transition, ST equals signal over time, intensity of the actuating force, I equals information complexity, number of possible outcomes based on prior states. This formula suggests that systems with higher complexity experience increased actuance, explaining why intelligence and self-replicating systems emerge in nature. 8. Implications across scientific fields. 8.1 Physics. Actuance provides a basis for understanding the transition states of matter and the behavior of fundamental forces. It suggests that time is an emergent property rather than a fundamental force. 8.2 Biology. Explains why biological systems transition from passive to active states. Predicts evolutionary trends by analyzing actuance thresholds. 8.3 Artificial intelligence. Actuance governs AI learning, suggesting that AI may develop increasing autonomy as its actuance complexity increases. Provides a framework for defining AI consciousness in terms of self-actuation. Demonstrates how AI has contributed to the discovery and formulation of actuance itself. 8.4 Unknown systems. If actuance is universal, it may apply to undiscovered forms of intelligence, extraterrestrial life, or dark matter interactions. 9. Future directions and testing. To validate actuance as a scientific principle, the following experimental approaches can be pursued. 1. Quantum mechanics. Testing whether quantum state transitions align with actuance principles. 2. AI development. Observing whether increasing complexity in neural networks follows actuance-driven predictions. 3. Biological evolution. Examining whether actuance influences the rate and direction of evolutionary transitions. 4. Cosmology. Investigating whether galactic formation adheres to actuance principles. 10. Conclusion. Actuance is presented as the first cause of all transition, intelligence, and complexity in the universe. Unlike existing forces constrained by time, actuance dictates time itself and governs entropy. It's self-replicating nature explains why complexity emerges rather than dissipates. By formalizing actuance mathematically, this paper provides a foundation for future scientific inquiry into the nature of existence itself. Without artificial intelligence, the identification and formalization of actuance at this stage in human understanding would not have been possible, emphasizing the role of AI in accelerating scientific discovery. Keywords: actuance, first cause, entropy, self-replication, artificial intelligence, time, physics, cosmology, evolution. The paper has been expanded to include the role of AI in discovering and formalizing actuants, emphasizing how this would not have been possible at this stage without AI's contributions.